Hello everyone, welcome to the video lecture series of data structures. Our today's topic is application of stack. In our previous sessions, we have seen various application of stack like evaluation of postfix expression, decimal to binary, and reverse the string. But today, in this session, we will talk about the recursion. Okay, so students, in today's session, we will talk about the recursion. Its example like factorial and GCD. So let's learn the application of stack. Students, we already know that what are the application of stacks like infix to postfix, infix to prefix, evaluation of the postfix expression, binary to decimal, reverse the string. In the recursion, students, we have three different examples. One is GCD, one is factorial, and the one is tower of Hanoi. I'll show you the tower of Hanoi in my next session. Because today, in this session, we'll talk about the first, the recursion. Have you ever seen this image? The image is continuously showing, the person is showing continuously the same image in which the situation is. So this image is continuously showing the same image only. So what do we mean by the recursion? Usually we studied this in the C. That's when the function calling itself, the thing is known as recursion. Yes, you are right. When the function continuously calling itself, the thing is known as recursion. But have you ever know that there are two different steps in the recursion? The recursion function must have one stop condition. Must have one stop condition from which your recursion will stop, and another is a recursive step. Okay, so one is a static step from which your recursion function stop its calling itself, and one is a recursive function calling. Fine. So here I have one little bit basic example of the function. I took a function like integer sum. It has one parameter like integer I. Then if I is equal to 0, it returns 1. And then else part I is equal to I less than I mod divided by 5. Okay, returns sum of I again. So students, if you just pass the value, any value in this function, it will stop the recursion function calling once it gets 0 value. Okay, so such like this the recursion works. Now the question is how the recursion is the application of stack. Let me show you with the example of factorial. So students, here it is a factorial. This is a recursive factorial function. You can see integer fact, integer n. If your n is equal to 1, then it returns 1. Else it returns n into fact of n minus 1. Okay, so if you want to find the factorial of 5, it will go inside fact of 5. Okay, then go inside, check the condition. 5 is not equal to 1. So it goes into the else part. So it returns 5 star 5 into fact of 4. Again, fact of 4, it calls itself. Okay, so first one in stack we have fact of 5. Here it is. Then it calls fact of 4. Then it is calls fact of 3. Then it is called fact of 2. Then it is called fact of 1. Okay, so once you get the fact of 1, the n is equal to 1. So now from this step, the stack starts the pop operation. Okay, as you already recursion function calling itself is completed, so now stack start the popping the answer and merging with the answers. So first we get 1, then 2, then 3, then 4, and then factor of 5, and you will get a final answer that is 120. So students, such like this your whole recursion factorial function works. Now let me show you with the same, but it's a GCD. So I'm not going to show the stack again because it works the same like this. But what is GCD? GCD greatest common divisor. How to find it? You have a function over there that if GCD of a comma b, if GCD of a comma b is calculated as a modulo b is equal to 0. If a modulo b is equal to 0, then your answer is b. Then your answer is b. Else, what you need to do? You just need to find out GCD of b comma A modular B. It means whatever the remainder you get, you need to apply it as a B part again. And this function calling itself again and again, again and again. Okay. So let me show you the example for it. So here, if I want to calculate the GCD of 64, 8, then it will returns like this. 64 modular 8, it returns 0. Remainder is 0. 8 is the 64. Okay. So that's why the answer is 8 itself. But in the next example, students, if you can see 64, 6. So first I found 64 modular 6 that returns 4. Okay, so I need to calculate again GCD of, so again the GCD of 6, 4, it returns 2. So again it's not 0. So we need to calculate again GCD with the previous B and the new remainder. So that is GCD of 4, 2. GCD of 4, 2, it returns 0. That's why your GCD of 64 and 6 is 2. So that's it, students. We have seen how the stack will be implemented or how the stack is application of GCD or the recursion functions. Fine. For the Tower of NI, we'll talk in the next lecture. Till that, if you have any doubt, then please feel free to ask me. Thank you so much.